Okay, so as I mentioned last week as well, the basis of our understanding of the memory system has to do with the time in which psychologists really started to study memories. And the first model, which is still applicable today, is the Akron-Shiffrin theory of memory. And remember last week I mentioned that this was the time of the computer. This was a time of those types of systems. So our initial memory system models were based upon the computer model. Okay, and what has been offered is that we basically have three distinct types of memory. All right, I want to look at something really quick. Okay. We have sensory memory, which is really just a very short memory system, and we'll get to it here in just a minute, of what you're experiencing, okay? And then the memory we attend to goes into what's called our short-term memory. And if you remember last week, I mentioned that this is kind of like the RAM, the random access memory in your computer, okay? Is that it's a limited space where you're able to work on the information you're receiving. You're working with what's going on, and you're deciding how to respond in some cases. So it's that sensation to perception area, but it's also where you're trying to decide, what to do with this information. If the information is significant enough, it's set to the third system, which is our long-term memory. Which, and last week I mentioned, we're not sure if there is actually a capacity to our long-term memory. Theoretically, because of the way the number of nerves that can be connected, it's pretty infinite about the amount of information we can actually store in long-term memory. The issue becomes when we think about memory and memory loss, it's really about retrieval problems and problems with retrieving those memories, albeit unless that area of the brain is damaged, such as, for example, in Alzheimer's disease, where plaque grows around the cell and suffocates it, and then that memory is then permanently lost, and a few of the other biologically based dementias. Okay. So this is kind of how the model works. Is we have sensory input from all our sensations. It goes into this sensory memory system. Those things that we attend to then are put in our short-term memory. Now, the original model says that we keep things in short-term memory based on rehearsal, okay? But we're going to need to do an update to this when we get to the newer model of what's called working memory, okay? And then what's happening, if you want to think about short-term memory right now, it's kind of the executor. It's the one who's saying, we need this information from long-term to understand what I'm sensing in sensory memory, and combining it to give us a conscious reality, a conscious experience. But again, as I mentioned last week, we also have an unconscious working memory, okay? That is happening more in the limbic area of the brain, where we do things like classical conditioning and operant conditioning. And as I stated when we were going over the different types of learning, that sometimes we don't even realize that we're creating a memory. All right. And again, I'll go back to clinical issues such as an addiction. Sometimes addicts don't realize why they're having cravings, for example. But those cravings, again, if we go back to classical conditioning, we're classically conditioned in the unconscious limbic area of the brain. So we know that occurs, okay? And then we have the storage and retrieval system with the long-term memory. The thing that we do know about the sensory memory system, so this is the sensory, is that when we've been able to capture it, We know that it's very rich and detailed information, and it's held in its original sensory form. So nothing has been done to it. So it's basically in its raw form, and our perception system hasn't taken over to start manipulating it, okay? We do know that it's very brief in duration. If you want to think about this again, remember the analogy with the computer. A sensory memory would be you press a key, right? So let's say you press the letter K and it appears on your screen. Okay, the duration between pressing the key and it appearing on your screen would be an example of sensory memory. Okay, and we know about this sensory memory because of things like iconic or visual memory or echoic or auditory memories. Sometimes, again, when we look at things like retrieval, people often hear things that they don't remember hearing, okay? A good example of auditory echoic memory, excuse me, is if you're talking really fast, and if you stop really quickly, or someone's talking to you really fast, and then they stop, and you kind of can continue hearing them talk, even though they've stopped. That's an example of this sensory memory system. And same with visual memory. So, when you burn out the retina of your eye by looking at the sun, and you look around and there's still that spot, right? That's an example of sensory memory, because the nerve in the eye hasn't recovered. So that memory, basically, of the sun is going to stay in your visual system, in that sensory memory system, until a new sensation is brought into the visual field, or the cells can start to fire again. Okay. The original model of short-term memory is it's those things that we attend to. It has a pretty limited duration of about 30 seconds. If you don't attend to something, so you attend to something and then you look at something else, and I do this all the time, right? I say, okay, I need to go in the kitchen and get something. And then my attention is diverted for a few seconds or whatever it may be. And then I go back and I can't remember why I needed to go in the kitchen. I think we've all had this experience. Like we started to do something, there was a brief interruption, and then for the life of us, we can't remember what it is we were going to go get or the like. And that is a notation to the limited duration of our short-term memory. Okay, it's because the capacity to keep that information in mind, as you would say, has ran out. It's gone. Okay. We also know that it has limited capacity of what is called 7 plus or minus 2 chunks of information. And I just remembered we were going to do a short-term memory test. So I'm going to get that ready, and we'll do it on Wednesday. I apologize. I just realized we were going to test your duration, and we're going to check. We're going to check to see how much information you can retain. But the majority of people can retain. So if you do the math on this, people can retain about 5 to 9 chunks of information. Okay. And again, last week I mentioned my number is around 4 or 5. I've known some people who have the ability to do up to 12 chunks of information at a time. And so there's variability in this. But what this task will tell you as an individual when we do it on Wednesday is it will tell you how much stuff you should focus on at one time to make sure you can transfer it from short-term memory into long-term memory. And we'll do this task on Wednesday. I just made a note to make sure that that's ready for us on Wednesday. And just so everybody knows, this capacity has been around for a very long time. It's what phone numbers are based upon. That's why phone numbers have the number of digits that they have, those kinds of things. And they're blocked if a number is 3 numbers, then 4 numbers, because the lower end of the capacity is 4, right? So most people can remember the 4 digits. And so we chunk that into information. We put the first 3 digits in one chunk, and then the second 4 digits in the other chunk. And then, if you have the area code now, it's chunked in a separate one. We have 3, 3, and 4, okay? And so that's kind of an example of how this type of information has been used practically, okay? And it's pretty good information if you're doing presentations. A PowerPoint slide should never have more than 3 to 4 bullet points on it, because if it does, it will be overwhelming to your participants. If you notice, most commercials are limited to about 30 seconds. If they're longer than that, we found that they're really ineffective in persuading the person's buying habits. So this is different ways this information could be used, just to kind of keep in mind. And I'll tell you on Wednesday, I'll also give you some study tips based on your number. So like, for example, if your number is 4, what this suggests is when you're reading a textbook, you should read 4 paragraphs, make sure you understand those paragraphs before going on to the next 4 paragraphs. And that's another way you could use the number that will help you find on Wednesday. So. And the phone number thing, this is what I mean by chunking. So we can chunk units. So with the phone number, we chunk it into 3. We have the area code, we have the first prefix, and then we have the 4 number. So it's chunked into 3s, and it's put into 3, 3, 4. So we have 3 chunks of information, which all have the capacities of 3 bits of information, okay? Rehearsal, to keep things in short-term memory. To be honest with you, and I, based on the video that we had on last Wednesday, rehearsal is not really effective in getting information from short-term memory to long-term memory. But rehearsal is a way to maintain it in short-term memory so you can do something with it, so that you can connect it to, or as he put, hooks into other information in the brain, make it significant in some way, those kinds of things. Rehearsal in and of itself won't guarantee that the information will be remembered, okay? So that's something to keep in mind. Now, the criticism of this version of the short-term memory is that it's really too simplistic. It's just based on rehearsal. It's based on, capacity and time limitation. But there's been some things added as research has been done on this system, okay? And really 3 important things have been added to the memory system, okay? Let me see, all right. And this is kind of the model of it. The things that were added over time is something we call the visual spatial working memory, or sketchpad, and what's called the phonological loop, okay? All right. And in the middle is what's called the central executive. Okay, the central executive, if we're looking at it from this model's perspective, is it's building an image based on our sensations we're receiving. It's interpreting that image based on past memories. And it's also processing auditory information and connecting it with past auditory information. And then it's connecting the two, okay? And making it so that we have an understandable reality of what's going on, okay? Now, where is the evidence for these? Well, you know, if you've ever had a song stuck in your head, that is because that song has gotten stuck in your phonological loop, okay? Meaning that it's just at the right tempo, the right speed and whatnot, that it's gotten stuck inside that system, all right? And really the best advice is if you've got a song stuck in your head, is you've got to break this loop that is occurring. And the best way to do that is listen to music that is opposite to the song that is stuck in your head. So if, let's say, you have a country music song stuck in your head, well, go listen to some heavy metal for a few minutes. And the idea is that because it's such a different tone, it'll break the loop. It's a different genre in this case. It would break that loop and hopefully it'll break that song stuck in your head. Now, I'll tell you, I try this all the time because I get lots of things stuck in my head and it goes around and around and around. It works sometimes, not all the time. I'm just going to put that warning out there. The visual spatial working memory, if you remember that video that we were watching last week about how memory experts build memories by creating a space for them. That you know, he gave the example of doing associative hooks and creating this visual space in your brain where you're putting memories, okay? This is the evidence for this visual spatial working memory, is that we have this space in our brain that we use in order to make sense of the world, to create a 3D space for us to work with information, okay? Now let's go on to long-term memory. It's relatively permanent with unlimited capacity, as we talked about. And there's really two types of long-term memory. There's explicit and there's implicit, or what's called declarative or non-declarative memory. For declarative memory, we have two types. We have episodic, which is memories for experiences. And we have semantic memory, which is memories of you add 2 + 2 and it equals 4, or you recite Pledge of Allegiance. Okay, that's all semantic. It's not based upon experience. Okay, so if you want to put this is experience. This is non-experience conscious effort. Okay. Implicit long-term memory. Okay, remember I was talking about unconscious memories. Okay, procedural memory is memories like being able to ride a bike, even if you haven't ridden one for a long time. Classical conditioning, that associative type of learning. Okay, and priming, and I brought priming up before when we talked about perception, right? Where we had that story that we told people about either camping outdoors or inner city living, and we gave a picture, and based upon that person's earlier experience, because of the memories that they were retrieving at the time, that then dictated what they were remembering episodically, okay? And again, I mentioned in my doctoral dissertation, I used a form of priming where I prime people for their social identity to see how that influenced emotions, okay? It's not something that people realize is happening at the time. It's not something someone's making a decision on, but it influences our behaviors and what we're experiencing, okay? So when we look at this, we have our long-term memory, we have explicit, implicit, and these are the three types, okay? People have heard the term muscle memory, okay? That's usually a procedural type of memory. A lot of these procedural memories can actually be stored in the spinal cord, which is kind of interesting. And when we talk about which memory is better, episodic memory or semantic memory, again, from our video last Wednesday, whenever we can make something into an experience, okay, it's going to, one, be easier to store into long-term memory, and two, it's going to be there much longer, okay? Semantic memories, as you guys probably have guessed with, you know, when you're studying for a test and then you go to the test and that memory is just not there. That's a semantic memory, okay? And they're more difficult to retain and to remember unless you have an experience with it over and over and over. And that's why in a lot of classes, we've gone to more experiential type of learning. You'll notice like in your science classes and those, they want you to actually be engaged with science and those types of things because they want you to have an experience because they know that having the experience will be much more meaningful than if you just try to learn the, you know, the chart for elements, for example, okay? So again, just to review, declarative memory is a conscious recollecting specific facts, events that can be verbally communicated, okay? In this study that is referred to right here, it's a recall of college Spanish. So it's recalling your foreign language class from high school or college. And what we know about declarative memory is that if nothing is done with it, it starts to decay, okay? And so if you're not constantly, well, not constantly, but if you're not using, for example, a second language, the ability to recall Spanish as the example becomes less and less available. Interestingly, it doesn't mean that that memory still is not within the brain system. It's that it's just more difficult to retrieve because we haven't been working with it for a while. So this is just the example. So number of years since Spanish was learned. So you have it right here. This is, of course, the control group, people who never took a class. And this is just showing that quick decay. I mean, by year 3, we've almost down to half of our retention of the language, okay? And by 50 years later, it's reduced a little bit more. So while the person understands Spanish better than the person who never learned it, the ability to recall and retain the original amount is greatly reduced. And as I said, there's 2 types of explicit memory. Episodic, which is the autobiographical memory, remembering, say, things like your 5th grade, your 12th birthday, high school graduation, those kinds of things. And again, semantic is that knowledge we have about the world, okay? Again, when we look at the accuracy, this one is more accurate, this one is less accurate, okay? And this is just kind of an example of a difference between the two. So episodic memory is about events and episodes. Semantic is facts, ideas, and concepts. How they're organized is episodic memories are organized in time, meaning that we usually recall them from beginning to end. Where semantic memory, it's by concept, okay? Emotions play a larger role with episodic memories than they do semantic memories. And that's one of the reasons that they're better stored in the memory system is because they have an emotional valence to them. So they have that extra hook to get it into the system. Retrieval, usually with episodic memories, it's a deliberate process, and with semantic, it's automatic. Usually when we report, we say, I remember versus I know. When it comes to the difference between these two, when we're talking about things like education and intelligence, education is irrelevant and intelligence is irrelevant in episodic memories, where they're pretty relevant in semantic memories. We have to have some level of intelligence, and we have to have the education in order to process that information. The interesting thing, again, and we'll talk about this, is semantic memories are based on facts, factual information. Episodic memories are based on events, okay? These are admissible in court. These are not admissible in court. And over the years, a lot of students have asked, well, what about Dr. Peterson? What about fingerprint information? That's semantic. What about genetic evidence? Isn't that semantic? That's knowledge. That's there. And the answer is that's true to an extent, okay? Because if you ever hear an expert providing information about genetics, for example, you know, that maybe the person's DNA was all over the crime scene, for example, you won't hear them say stuff like the DNA found at the crime scene matched a sample of DNA and it was by this percentage and by this. No, what you hear is a person's experience developing that DNA information. So they'll go, well, I collected samples from the crime scene. We went back to the lab and we did this and we did that. Because if they just give the facts, that's not an admissible thing. That's why you don't see just reports going to the judge and the jury, giving them the information about the results of a genetic test, because that's not admissible in a court. They have to go in and provide their expert testimony, which is an episodic memory. It's not a semantic memory, which is kind of an interesting thing. And of course, what that has done over the years is we also know that episodic memories are more valuable to experience, okay? And so you probably noticed that there's been a lot of people who have been put in jail based on genetic evidence, and then years later, some more research was done on the genetics, and they're being released, okay? Again, it comes down to, it's because the quote unquote expert witness provided their opinion based on their experience with collecting that genetic information. It's not because the actual analysis, the semantic fact of the situation was provided. So just kind of an interesting thing when it comes to things like legal testimony, as an example. Non-declarative, again, we have three types: procedures, that's kind of the riding the bike, classical conditioning, and priming. Okay, and they are all affected by experience without any conscious recollection. So just to kind of keep that in mind. Okay, the way our memories are organized is in two ways. One is through schemas. And if you remember when we talked about development, we talked about Piaget's idea of schema. Schemas are a unit of information or a script of how an event should be or shouldn't be, okay? And we know that memories are connected through this connectionist model. Our brain is a rapid network, okay? And so memories are really a collection of experiences, not just a single experience. So in the connectionist model, we have all these schemas, okay? And in order for them to be remembered, they're connected with each other. Whoops. Okay, this way. All right, we'll do some more arrows. Okay. Now, why this is important, all right, I mentioned things like Alzheimer's, okay? And in Alzheimer's, basically what happens is, you remember we have nerve cells with the axon, and on those nerve cells, we have this myelin sheath, which is these little fatty nodes, okay? And what happens in Alzheimer's disease is a black plaque starts to grow on this myelin sheath. You kind of think of it as almost like rust. And what it does is it grows and it tightens around the axon and basically suffocates the nerve cell, okay? And then once this nerve cell is dead, so let's represent it this way. When this nerve cell is dead, because it's not sending or receiving any more information, it then, without any of the plaque or anything, because this connection is not going to be being exercised, it'll start to kill this cell and start to kill this cell, okay? And, in some of the treatment for Alzheimer's, that's why they do memory practice tests, because hopefully maybe if this connection can stay strong enough, long enough, that maybe these two memories can be retained for a little bit longer, okay? So that's kind of an example of how different disease states can affect this connection model that we have, okay? It's also why sometimes we can't remember something, because sometimes we just don't practice with this one memory very much. So even in a non-disease state, if we're not looking at everything something is connected to, sometimes those memories will start to decay in that connection or in that network, okay? I had an example for this one. I'm trying to think of what it was. This is also, again, going back to studying. This is why it's so recommended that when you're studying and you're trying to remember things, you connect it with other things that you know about in your life, that you have memories for. And the more you can make those hooks into those other memories, the stronger that thing that you're trying to memorize will be, okay? Okay, and this is just kind of going over the circuitry of neurons that we just talked about. Neurotransmitter involvement. Again, we're looking at serotonin, dopamine, and ACH. Acetylcholine as playing major roles in those areas. So if any of those neurotransmitter are not present, they can go into that. A good example of this is low levels of ACH or acetylcholine and low levels of dopamine are associated with not only dementia, but they're associated with Parkinson's types diseases, where you get uncontrolled tremors in the body that can't be controlled. So. I do want to talk about smell, because one thing that, so we mentioned in this class before about, when we look at visual systems and sensory systems, the nose is the only one that is directly connected to the cerebral cortex, okay? All of our other sensory systems have to go through the limbic system first before it's sent up into those higher areas of brain. The exception to this is smell. Smell simultaneously goes to the cortex and to the limbic system at the same time, which makes smell our best memory system out of all the memory systems we have for different sensations. We mentioned auditory, we've mentioned visual, and we've done lots of research on those. But what we have found is that smell is the best memory that we have. And it kind of makes sense, when you smell baked bread, it starts to remind you of a lot of different things. When you go and visit grandma's house, usually it's not the sight of grandma or hearing grandma. It's usually when you walk in the house and you get that smell of being home with grandma, as an example. A lot of trauma, people who have gone through trauma, visual triggers, auditory triggers, yes, they exist, but the strongest trigger for people who have gone through trauma that put them into a spiral is the smell. I know working with again, rape victims and stuff in my previous careers, is when we were going through the triggers the survivor had, we always identified the smell of what it smelled like during the assault, because that usually is the biggest trigger that assault victims have, is just the smell of a certain cologne or something like that. So yet we don't often give this a lot of credit when we think about trying to remember something. Okay, and yes, it is true. If, for example, and when you're studying and you're trying to remember something for a test, I recommend if you like perfume, or if you have a favorite kind of fruit or candy that has a certain smell, when you're studying, have that scent with you. And when you go do your exam, make sure you wear that perfume, or you have that candy around, or that smell around, because it's actually shown to increase test performance. So just another example of how you could use this material to improve your performance in school.
Dr. Peterson, I have a quick
Yes.
question.
Yes.
With a lot of COVID and how it also affects people's smell, has there been any research as if the smells, a lack of smell or not returning a smell, has that affected the memory of people? Is there any new articles or any new studies on that you know of, or if you know anything, or do you think that would affect anything?
Yeah, so there's been some correlational research, especially coming out of our COVID-19. One of, as mentioned, one of the major symptoms of the virus is the loss of smell, and that's where a loss of taste of food comes from, is that loss of smell. And what we have found is that the more of that incapacity to smell, we're actually finding that those are the individuals that are also having memory problems. So one of the long-term effects of COVID is memory loss. And we're finding the more the loss of the ability to smell, the more memory loss that we see. So yeah, that is something that we're finding. I'm going to withhold a little bit of judgment on that because there's only been a couple research articles that have been done on it. So I want to see if there's some replication on those articles before I, say, yes or no. But there definitely is some evidence that suggests that those types of symptoms that occurred during, for example, having COVID does affect the memory. Does that answer your question, kind of?
Yeah, I mean that they are doing some research on it and that it is a probability.
All right. You kind of cut out there in the end, but I'm going to assume. Okay. Okay. So where in the brain are these different types of memories? Thank you. Okay, thank you, Isabel. I'm sorry, I kind of was cutting out a little bit. Thank you. All right. Explicit and implicit memories, they actually have different regions of the brain that are involved, except for, of course, the hippocampus, which when we did the biology section, if you remember, this was always mentioned when we were talking about memory, okay? But kind of think about this again. Of course, the frontal lobes are going to be involved because that's our conscious processing area. Interesting though, the amygdala is involved, and if anybody remembers the associations of the amygdala, it deals with emotions. Okay. Mercedes, I'll actually get to that in just a second because that's an excellent question. Okay. And so again, I just want to emphasize this: explicit memories, yes, they do have a rationality behind them, but they also have an emotion. Okay. And whenever we can tie something to that emotional state, we can tie it to a more long-term memory. Implicit, of course, the cerebellum, because it deals with coordinated movements, those classically conditioned. The temporal lobe, which again is associated with conditioning and classical and operant conditioning. So I do want to hit Mercedes' question about what about dreams? Where do they play into this? All right. Memories are consolidated when we're doing a certain type of sleep called REM. It's rapid eye movement. And we studied this a little bit when we did sensations and perceptions. Basically, what happens during a cycle of sleep, and it's kind of cool, about 60 minutes into sleep, most people start going into REM. REM is when the eye starts rapidly moving back and forth. Okay. And if you ever want to do this, if you have a spouse or a kid that you like to experiment on, if you just take a small light and about 60 to 90 minutes into their sleep, kind of shine it on their eyelid and you'll see their little eyeballs going back and forth. Okay. Rapid eye movement is when we are dreaming. This is the dream state, but it is also when memories are being consolidated and being formed. Okay. And the current theory on dreams is that dreams are really based upon our experiences of the day. Now, when I talk about experiences, I'm talking about unconscious and conscious experiences. So it's hearing certain sounds that we didn't recognize or thinking about certain experiences we didn't realize we were thinking about, learning something different. And what the theory is that dreams are kind of this way that the brain is processing your information from the day and consolidating that into the memory system. Now, it's important to remember the brain is not logic. and dreams sometimes aren't either. And so the hard part that a lot of people have with this is that while my dreams don't really represent, you know, what I happened during the day or whatnot, while the brain also isn't going to process that information the same way that you experienced it consciously. Okay. Now, where does the evidence for this come from? We know that, you know, if we take there's animal experiments, and there's experiments done in sleep labs where, you know, a person will report a dream over and over and over, and then they'll record what they did during the day. And then part of the experiment is if there's some consistencies in the dreams, we alter their day. Okay, so let's say a person keeps having a dream about flying, and every day, this is just an example, every day they drink a cup of coffee. And we notice this consistent association between drinking that coffee and dreaming about flying. So what we do is we tell them not to drink coffee, and altering it this way and whatnot, we find that, you know, in this case, maybe the dreams about flying go away because it wasn't part of that person's experience during the day. Okay, so that's where the evidence for dreams being a memory consolidation system, and it can get pretty deep, especially when people, again, when we talk about things like trauma and those types of things, or happy, extremely happy experiences versus extremely awful experience, and if they were important to the person's life, that can become a consistent dream state for that individual. Does that answer your question, Mercedes?
Yes, it does. Thank you.
You're welcome. Okay. And I do just want to mention a few other things that deal with memory and retention of memory. One is called the serial positioning effect. This is a tendency to recall items at the beginning and the end of a list more readily than those in the middle. And it is true when we think about experiences, right? When you think about, let's say, going out and partying, a week later, when everybody is reminiscing, they might remember some really crazy things that happened. But usually what people are reminiscing is when everyone showed up and when everyone was getting ready to leave. Okay, this is called serial positioning effect. It is also, and this is a good thing to do when you're studying, right? So when you're studying, you should keep this in mind. So let's say you're studying a chapter in a book, and that book that chapter has 25 pages. So in the beginning, you might read from page 1 to page 25, right? That makes sense. But the next time you study, start on page 10 instead. And then the next time you study, maybe start on page 20. But don't always start the first place and the last place that you began with. If you have to memorize a list, don't always start from the first item to the last item. Go in the middle and change it up so that your recall is better. And then Tommy just put in here a question about deja vu, and I think this actually has it in here. Trying to remember, I thought we had something in here about deja vu. Yeah, kind of tip of the tongue phenomenon. Effortful retrieval of known information can retrieve some information, but not all. Oh no, that's a different. Let's see. Okay, I thought we had one on here. Tommy, but so deja vu memories, okay? Again, when we go back to the memories that are most easily remembered, remember their smell. And also remember that a lot of memories are remembered unconsciously, and then there's triggers in the environment that trigger those. It doesn't take an entire scene for you to remember something. It can be something as slight as a smell, something just very slight of a visual experience. And all of a sudden you remember being somewhere that maybe you've never been before, right? That's kind of the deja vu, or thinking you've experienced this, even though you have no memory of experiencing it, okay? What we think is going on with deja vu memories is that there's a slight trigger in the environment that then your brain has to do something to make sense of. And so it will create a memory to its most closely related information that it's receiving. That's what we think is going on in deja vu memories, but the research and the information is still out about that one. But it's a very good question about that particular experience. And I think there's a slide in here on it that I'll try and find for Wednesday. Okay. Trying to just sign what we've not gone through before. So again, when we talk about autobiographical memories, lifetime periods, reminiscing bumps, general events, event-specific information all play a role into this, okay? And there's certain kind of memories that really are based upon emotional connection. And I think this kind of gets to the deja vu question as well, okay? Is there something called flashbulb memories, okay? For example, a flashbulb memory is when you ask, what were you doing when the planes crashed into the Twin Towers, okay? And most people, because it was so emotionally experienced, they have this memory of exactly what they were doing at that time, okay? The thing that we know, though, is that, again, it's an emotional experience. And so it's not always accurate, okay? For example, some of the research that was done on 9/11 is we went back and we talked about this flashbulb experience, knowing that they're based on emotions. And we asked people to specifically tell us what were they doing right at that moment when they heard, okay? And I cannot remember who was playing, I apologize, who was playing the World Series at that time, okay? But the person said, it was, his home team was playing in the World Series. And he mentioned that he was watching one of the World Series games at the time, and he could specifically remember looking at the TV and watching the game. And he even said the score was this. The problem is he was recalling a game that was actually 3 days later in the evening. Not the game, not any game associated with 9/11. In fact, there wasn't a World Series game on 9/11. There no game whatsoever. But he recalled a game that occurred 3 days later because he just remembers, because it was his home team. That's who he was cheering for. And so he associated those two emotionally charged memories together. And so this is the thing about flashbulb memories, just so everybody knows, is that these are based on emotions. They're not based on experience. They're not based on semantic lived experiences, okay? And we know this can be true for very traumatic events, all right? That trauma can play a role in a person's experience. And so probably the best example that I can give of this is that a lot of children who have been sexually abused and they can't remember the details of it. They can also remember the details of other things that were associated with that trauma. Okay, this is often why pictures of their offender or whatnot can't really be accurately drawn. That's why most, when we talk about people who do those composite drawings of offenders, they usually don't just use one person's memory of it. They, if it has multiple victims, they'll take multiple victims' memories of it, and then they'll put them together. That's why they call them composite pictures, because they're pictures from people who had witnessed or had been that, and then they combine them all together. Okay. And then there's the idea of repressed memories. I can tell you that we really cannot repress a memory, but our memory system has safeguards in them to make it so those memories don't affect us. Again, I think I mentioned this before. Our brain's primary job is to keep us biologically alive. Secondarily, it's to give us all the experiences, human experiences that we have, okay? And so when it thinks a memory is not safe enough for the individual to have, it can block the recollection of that memory, okay? And probably the best example, the research example, when they say, well, people can forget, yes, you can forget. But when we say, can a person purposely repress a memory? The answer really is no, because if, for example, if I had you put in your mind, yeah, Angela, that's a very good example. Yeah. Okay. If I have you put in your mind a picture of a pink elephant, and then I say, repress that memory of the pink elephant, and let me know when you have repressed that pink elephant, okay? The problem is that once you repress it, and then you can say, Dr. Peterson, I've repressed it, I don't remember it. Guess what? You're remembering it. And so the idea of purposeful repression is not something. People can't purposely repress a memory. Now, can we forget it because it's been decayed and whatnot? Of course. But as far as purposely or can we do that? The evidence is weak. Okay. All right, we're running on civil and civil. Yes, those are very good examples. All right, we're running on we're near the end of class. Does anybody have any questions from today's class? Very good questions. Thank you for those questions, by the way.
Dr. Peterson, it's Angela. Is
Yes.
the slides going to be on Canvas, just so I can review what we flipped through on the PowerPoint?
I think they are. Let me look really quick because I thought I posted them. Let me look and make sure. Oh, I have not. I will post those in Canvas today. Oh, no, they are here. So under class lecture, just after the October 12th class and before the October 9th class, there's a PDF called Psych 101 Complete Slides. that has all of these in it. Okay.
Okay, just wrote it down. Thank you.
Okay, you're welcome. All right. Oh, Mercedes. I didn't post that either, did I? I'll post the one from last week's lecture. I just realized that. Thank you. Last week. I didn't see that on the list. I'll make sure I do that. Thank you. Okay. Well, if there's no further questions, let's go ahead and end class for today.